The Pythagorean Theorem, possibly the single most used theorem in all of geometry. You're going to find that this theorem is going to be used to find distances all over the place. So, we know that the Pythagorean Theorem is attributed to Pythagoras, even though he totally didn't invent it. We knew about the Pythagorean Theorem for thousands of years beforehand, but here it is. Now, most students are able to just rattle off the Pythagorean theorem anytime someone asks. A squared plus b squared equals c squared, which is fine, but you have to remember what a, b, and c represent. Okay? Because a, b, and c by themselves are not terribly useful. We don't know what a, b, and c are supposed to stand for. So the way I write this theorem is leg squared plus other leg squared equals hypotenuse squared. That reminds me that A and B have to be the legs, and C has to be the hypotenuse. It doesn't really matter which leg is A and which leg is B, but for myself, I tend to choose the shorter leg for A and the longer leg for B just so that there's no confusion whatsoever. Okay, so now that we know the Pythagorean theorem, we're going to get sort of comfortable with it. Let's do a few examples, starting with find the value of x in the triangle shown below. Now, as usual, I'm going to give you a few minutes, or I'm going to give you a few seconds. Go ahead and pause the video really quick. See if you can find out what x is. Fair warning, you are either going to get a square root or a decimal, so make sure you keep that in mind. Give it a shot, try to solve for x. Ready, set, go. Okay, so it's important to remember, once again, looking back at the Pythagorean theorem, that A and B represent the two legs, and C represents the hypotenuse. In fact, I'm even going to go ahead and label these. So we're going to call this A. B is red and C is blue. So we're going to call this B, and we're going to call the hypotenuse C. Okay? So, A squared, well, A is x. So A squared would be x squared plus, well, B is 7. So x squared plus 7 squared equals, C is 9, 9 squared. And now it's just a normal equation that you solve normally. 7 squared is 49. And 9 squared is 81. Should not need a calculator for that. Now, I see two steps here. Step 1, subtract 49 from both sides. 81 minus 49, let's see, we can do this without a calculator. 81 minus 50 would be 31. 49 is one less, so 81 minus 49 should be 52. Or, I'm sorry, should be 32. And then we square root both sides. Remember that the opposite of squaring is square rooting, not dividing by 2 or anything like that. Okay, so moving down to give myself a little bit more room, we get x equals the square root of 32. Now, in Khan Academy, it's multiple choice, right? So you would check and see, is the square root of 32 one of the answers? But let's take another look at how I can simplify this and without using a calculator and coming up with a horrible, ugly decimal. So I'm going to do a factor tree, okay? So yes, the square root of 32 is a correct answer, but it might not be what the answer looks like in Khan Academy. So let's look at a couple of alternative ways that you could write that answer. So 32, well, let's see, that's 16 times 2. 16 is 4 times 4, and each of those 4s is 2 times 2. I don't know why I circled those 4s. So the square root of 32 is the same thing as the square root of 2 times 2 times 2 times 2 times 2. Right? 32 is 2 times 2 times 2 times 2 times 2. If you don't believe me, grab a calculator, check it out yourself. Well, I see a pair of 2's here that I can take the square root of. 2 squared, well, the square root of that is 2. And hey, look, I see another pair of 2's. And then unfortunately, there's this one lonely 2 left over that doesn't get to leave the square root. So that stays the square root of 2. So here, we've got 2 squared. Here, we've got 2 squared. So we can take the square root of each of those. And we end up with 4 times the square root of 2, which is an equivalent correct answer. Again, if you don't believe me, take 4 times the square root of 2 and the square root of 32, put them both into your calculator. Either way, you should get approximately 5.66. All three of these are 3 different ways of saying the same answer. However, I want to make it clear that this one and this one are accurate. Whereas if you find a decimal approximation, it is just that, an approximation. You might end up getting a problem wrong on Khan Academy because you used an approximation and not the actual exact square root. So this was kind of 2 problems in one. The first problem was actually using the Pythagorean theorem. The second problem was simplifying that square root. Now, for those of you who are still having a hard time simplifying square roots, I will go ahead and link a video right here, right now, that will give you some extra practice working on simplifying radicals. Let's move on. Here we have another triangle. This one has legs of 3 and 7 and a hypotenuse of x. So we will go ahead and set this up really quick. As usual, go ahead and pause, take a couple of minutes, see if you can do it yourself. Ready, set, go. Okay, so since we have the 2 legs, and the hypotenuse is what we're looking for, our setup should look like 3 squared plus 7 squared equals x squared. Because the x is the hypotenuse, the longest side, it is by itself on the right of the equals. Okay, well, 3 squared is 9. 7 squared is 80. Wait, I was about to say 9 squared is 81. Whoops. 7 squared is 49. And that equals x squared. So we get x squared equals 58. And that makes x equal the square root of 58. Now, once again, We're going to zoom in here, see if we can't come up with a good simplification for square root of 58. Well, 58, I don't really know what that's divisible by, but it's even, so I know at the very least it's divisible by 2. So it's 2 times, I'm actually going to use a calculator. 58, oh, it's 26. 29. See, this is why I use the calculator. 29. Well, 29 is prime. 2 is prime. There is no simplification we can do here. There aren't any pairs of factors that we can rescue from the radical. So this is our final answer, square root of 58. For our third example, we're going to pull from the Pythagorean Theorem challenge problems. So I'm actually going to zoom out just a touch. The Museu Blau in Barcelona, Spain, I totally butchered that pronunciation, is a natural science museum built in the shape of a triangular prism. A prism just means a three-dimensional shape that has the same shape on the bottom and the top, in this case a triangle. The base of the building is an equilateral triangle 180 meters on each side. So it's an equilateral triangle, and it's 180 meters on a side. And the height of the prism is 25 meters, which I don't think is going to matter. Find the height h of the triangular base. See, it's only asking us about the base of the prism. We don't care about the height of the prism. That's not terribly interesting to us just now. Okay, so we want to find the height of the triangular base, and it gave us this very helpful little diagram right here. So I'm just going to zoom all the way in on this, because this is really all that we're interested in, okay, using. So we're going to take one of these right triangles here, okay, and we know that its hypotenuse is 180 meters. Now, take a second, really quick, on your own. Can you tell me how long this side should be? Take a moment, look at the diagram, think it over. Now, hopefully you saw that this bottom side here is half of the whole bottom of the triangle, which would make it 90 meters. And we have h. From there, setting up the Pythagorean theorem should be pretty easy. 90 squared plus h squared equals 180 squared. Again, I know I keep saying this, but make sure that your hypotenuse, the longest side, is on the other side of the equals by itself, because that's C. Well, 90 squared is 8100, and 180 squared is 32,400. Yeah, the numbers are pretty big, but we've got a calculator, so it's not a big deal. We're going to subtract 8100 from both sides. We get h squared equals 324 minus 81. We get 24300. So 24,300 is h squared. And the square root of 24300 is approximately 155.88 meters. Notice how in this problem, because we're using a real-world situation, I don't mind being a little bit inaccurate and getting a decimal. Because in real world problems, having a decimal that's a little bit inaccurate is better than having a square root that is perfectly accurate but nobody can understand. Okay, last example. Which of the following sets of numbers could represent the sides of a right triangle? In other words, which of these four sets of numbers follows the Pythagorean theorem? So we're going to check each of these and see, are they consistent with the Pythagorean theorem? So let's start with A. Is 5 squared plus 12 squared equal to 13 squared? I'm going to put a question mark over the equals because we don't know yet. Well, 5 squared is 25. 12 squared is 144. 25 plus 144 is 169, which is indeed 13 squared, also 169. So yes, A is a Pythagorean triple. Let's take a look at B. I should probably write a little bit smaller. 24, 24, and 30. 24 squared plus 24 squared equals 30 squared. All right, well, in my calculator, I say 24 squared plus 24 squared equals, and I get 1152. 30 squared, I get 900. So those are definitely not equal. So B doesn't count. Okay, how about C? 259. Well, 2 squared plus 5 squared, does that equal 9 squared? 2 squared is 4. 5 squared is 25. 9 squared equals 81. Pretty clearly, 29 and 81 are not equal. Now, this last one is kind of tricky, and I actually had a student email me about this very problem. Take a very, very close look at problem or at answer D and see if you can figure out why it might be a little bit tricky. Take a couple of seconds. So remember that C is always supposed to be the largest. That's C. They put it in the middle specifically to mess you up. They don't have to put the biggest number in the third position. You are supposed to know that the biggest number is C. So the question is 36 squared plus 77 squared equal to 85 squared? Now, if you didn't notice that 85 is the biggest number, you might have set this up very wrong. Okay, so 36 squared plus 77 squared, I get 7225. Is that equal to 85 squared, which is also 7225? So yes, these two are indeed equal. So these three do count as a Pythagorean triple. So the correct answer is A and D. So with that in mind, you should now be able to do the two topics, use Pythagorean Theorem and Pythagorean Theorem Challenge. Now, the Pythagorean Challenge is called Challenge for a reason. These are supposed to be kind of tougher problems, so please do persevere and give this a shot. I do hope to see you all during my streaming office hours. I should be starting at about 4 p.m. right here on this channel. Again, assuming that all the tech works the way it should work. If it doesn't, if for some reason I find myself unable to stream, I will go ahead and put out an announcement on Google Classroom letting you know that you don't have to be in stream or that I'm not available to be in stream. Once again, you don't have to come to the streaming office hours. They are there for your benefit. I'm not taking attendance or anything. So I hope to see you there. I hope you're all staying healthy and happy, and class dismissed.